Discussing world-changing ideas through real conversations, exploring the potential of technology to solve the most critical challenges facing business, people, and the planet. Coming up.
We have quite a lot of people coming to the factory, and usually they are amazed. We have the AIVs running around, we have robots doing parts of assembly that earlier on done completely by humans, and then of course we have the private wireless networking, meaning the LTE and 5G networking providing connectivity. On top of everything we have the digital twin and its use cases.
This is the Real Conversations podcast by Nokia. Here is Michael Hainsworth.
Oulu, Finland, population 200,000. On the outskirts of the city north of Helsinki sits the factory of the future. It's producing base stations for Nokia and producing insights into the fourth industrial revolution, thanks to its digital twin technology. Esa-Matti Sarjanoja is the manager of digital manufacturing for mobile networks there, and his research is so advanced, he's already working on the next generation of the technology that makes it a facility that's both a factory and a laboratory.
We are an NPI factory, and that means that we are, in a way, like a laboratory, as you mentioned, for our R&D. So basically, we kind of ramp up how to manufacture these base stations. But then again, we also have some volume production. So basically, NPI, new product introduction factory.
And that gives you the ability to learn as you go while exploring what the opportunities are within the fourth industrial revolution.
That is correct. But then again, if we are talking about us as a laboratory, we are still a manufacturing unit. So all the things that we do, all the softwares that we create, they have a price tag, and that reflects on the prices of how much does it cost to manufacture these base stations. So basically all the Industry 4.0 initiatives that we have taken must have a payback time.
A factory like this requires a lot of Internet of Things based technology. That's your background?
That's right. So before I joined Nokia, about 5 years ago, I was working for VTT, the Technological Research Center of Finland, and I was doing IoT-related research there for approximately 10 years. And since I joined Nokia, first as a lead developer, we started to build doing the digital twin of all factory devices, kind of on top of my former knowledge. But nowadays I'm leading a team of highly skilled experts doing the same thing.
The concept of a digital twin is already on its second generation. Tell me what a digital twin really means to you.
Yeah, a digital twin, in my opinion, is more a data-related thing. So kind of the thing that you see from an iceberg. I mean that sometimes people refer to digital twins on augmenting real-time metrics on top of a 3D model. But in my opinion, it is kind of things that you don't see, how to model physical assets, or in our case also non-physical assets such as software components and factory operational processes. So how we model those is that we can model the parameters, the telemetry, the components that the assets or the digital twins consist of, relationships to other assets, and also the command layer, how to talk back to the devices.
Oh, that's fascinating, because I can imagine a lot of us would think of digital twins as being focused primarily on monitoring how an assembly line works, making sure that the sprockets are turning properly and when they might wear down and how to replace them before that breaks down so that you can ensure a smooth running factory. But you also have system on a chip technology with firmware. You've got computers that are running operating systems. You would have to keep track of all of that too.
Yes, that is correct. You mentioned the sprockets running in the production. And I also said that we don't necessarily mean that a digital twin is augmenting things on top of 3D models, but we actually do have that also. But this is kind of the presentation layer to what we have stored in our digital twin. So you mentioned how to monitor how our production lines are working and so on, how to kind of predict in advance if something is going to be happening in the production. These are the things that we are trying to solve and somewhat have been solving with our digital twin core.
I can imagine you can't really do a lot of that work without standardization. What role does standardization play in ensuring the smooth functioning of a factory in the fourth industrial revolution?
Yes, that is also a very good question, because we have been struggling a bit with the standardization of digital twin models. So when we started, there were basically two different competing models, and we selected the one that has commercial background, but which is still open source. So we have a definition language that is supposed to be compatible with the definition languages that the other companies are using. So in terms of if we are looking into, for example, metaverse, I think that these things have to be decided together.
So there's a collaborative advantage to working with partners.
Exactly. If we were to share information with our partners, they have to be somewhat compatible with the way we are doing things. Of course, the interfaces that we have are standard already, like in how the interfaces work. But then again, the way we model our digital twins, it also must not be our own thing that we only use by ourselves.
I want to get deep into the particular abilities of and the use cases of your digital twins, but before I do, I'm fascinated by your partnership with Microsoft. You know, speaking about a collaborative advantage, you've got the Azure platform and ChatGPT. I guess it's one thing to have like an IoT dashboard for the factory, but to be able to ask the factory a question and get a detailed answer, I guess that takes the fourth industrial revolution really to that next level.
Yeah, you're correct. And I wouldn't say that we are already there, but this is the way we are heading now. So we are, in fact, we do have access to the Azure OpenAI platform. And this is what we are using to make it possible for our factory personnel who not always are technical computer-wise. So basically, we want them to be able to ask questions in plain English and getting results in plain English. And having all the data in a single format in our digital twin core makes this hugely easier. So we don't have to capture the data from like millions of different data sources. Our algorithm has to be compatible with only one or two.
It's an important issue in the world of AI to ensure that the algorithm you're creating isn't a black box, that you have an understanding as to why it did what it did or why it said what it said. It sort of reminds me of the TV show Westworld, where the scientists are debugging the AI of the robots to determine why they said what they said or what they did, just by asking them, why did you say that? And you get the answer.
Yeah, that's a good point.
Analysis. Why did you ask me about my son?
We've been talking for some duration, and I haven't asked you a personal question. Personal questions are an ingratiating scheme.
I see. Continue, Dolores.
I'm a bit concerned about using this like a deep neural network based algorithms, because you cannot be exactly sure why is it making the decisions as the way it is. It is somewhat a black box, but then again, we can kind of validate the results ourselves quite easily.
Let's talk about the three key types of use cases: safety and security, productivity, and reducing time to market on a prototype, and the operations use case. From what you've learned over the last 2 years working on this project, which of those use cases has surprised you the most?
I would say the use cases that surprised me the most are related on how just bringing the data visible for the people has a lot of value, meaning that our analytics based on the lead times in our production, I mean the manufacturing lead time, starting from when the first soldering board starts to get its serial number until the point where it's packed to our customers. We have created tools to give an overview on that data, but also capability to kind of deep dive really into the like a single kind of, we are talking about like a digital twin of our product in terms of how it's moving inside our production. So we have stored all the actions that have been made to it. And this has just bringing the visibility, how the lead times kind of build up. We have been able to decrease the lead times 30%.
So you've reduced the lead time from when a product goes from basically a little more than a concept to a box that's getting shipped to the customer by 30%. That must be an incredible, not just time savings, but cost savings as well.
Yes, exactly. And thinking about this a bit, so we have created, let's say, technologically more advanced use cases on top of our digital twin. But this use case has been the most beneficial for us money-wise.
Safety and security could be broken down, I suppose, into two separate use cases when it comes to digital twins. How are you using digital twins and IoT for safety?
Well, basically we have two different kinds of indoor positioning systems in our factory. So we have the AIVs, the automated intelligent vehicles that are basically capable of locating themselves very accurately. And then we have component and material trains that are operated by factory personnel. And sometimes when these two kind of devices or machines are on the same corridor, sometimes the AIVs just don't know what to do. But we created a use case on top of that, and we installed a tag on the material train so we can track also that one. And we were able to give commands to the AIV to take a detour if the material train is approaching the corridor that the AIV usually uses. So this is, I'd say, closest example of how we could utilize the digital twin, and as we are able to harmonize certain things such as the different coordinate systems from these two completely separate systems into a single harmonized form.
What's your favorite use case for digital twins when it comes to security?
I would say it is how we are able to utilize the same core that we are using for monitoring the how our placement machines are doing, how the AIVs are doing. We are using the same core to capture cybersecurity related information from our factory computers. So basically, it's not a secret that operational technology sometimes is restricted by the vendors in a way that, for example, the operating systems cannot be upgraded to the latest version, or the vendors might even say that we are not able to install certain cybersecurity related applications on the machines.
And so you need to understand the vulnerabilities associated with that chip so that you can maintain the cybersecurity of the entire factory floor.
That is correct. That is correct.
As far as productivity and time to market is concerned, first of all, it's fascinating that you can reduce the time to market by 30% or so. But tell me a little bit more about how digital twins come into play on TTM and the increased productivity that you need to get out of a factory.
Yeah, I would say that it comes from the collaboration with our kind of supply chain, which we have increased significantly last year already. So basically, we have given access to our tools to the closest partners inside Nokia, and this has proven also quite successful for us. But of course, we are still waiting for the big fruits to drop from the time to market side. So basically, we would, as I mentioned, we kind of try to improve the manufacturing process all the time in cooperation with the R&D and with the supply chain colleagues. So what we would like to do is that we would like to connect how our production process affects, for example, the yield. If, for example, the component vendors, the component lots chains, if there are certain differences between the soldering boards, if we buy them from different vendors, because sometimes these things kind of stack up. We might have certain combinations of components, soldering boards or stencils that we are using to kind of press the soldering paste to the soldering boards. Sometimes the combination of these three cause trouble, even though they are kind of specified that we should be fine. But our board assembly specialists who are highly skilled in this sense, they might know that you are not allowed to do a combination of this vendor and this board for some reason, because they tend to fail at some point. But in here, we are talking about perhaps tens of thousands of different variables that are or are not linked to each other in terms of yield. And we would like to automate this process.
That's really remarkable. I had no idea that you could run into incompatibilities with a certain type of solder, with a certain type of board. And maybe there's one guy in the factory who knows this, but if he's not working that day that you requisition this necessary equipment, then you're going to have failures at some point down the road. So this is a perfect use case for AI, IoT, and a digital twin that can recognize well before the product enters the beginning phase of production, to ensure that you don't have these failures sometime down the road. And this is, you guys are only, 2 years into a 3-year strategy to learn how to build that factory of the future.
Yes, exactly. So you are referring to the 3-year strategy on how to enhance our time to market process. And this is what we are kind of heading at. And we are expecting huge results already this year.
After this podcast, learn more about this and other insightful topics by going to nokia.com/thought-leadership. There you'll find additional information linked to today's podcast. So if this is year 2 of the 3-year strategy, what have you learned so far?
So
Which is a pretty big question.
It is quite a big question. So when we deep dive into some topic that we haven't done earlier on, we just understand how little we actually stand on the field. But this cannot stop us. So we are not stopping anywhere. We have initiated discussions with, for example, the companies that make our designer tools, and discussed how we could integrate directly into the tools. If we were to solve the problem I described, we would like to first start giving advice to our board assembly specialists. But the next step would be giving advice to the designers in their designer tools. But this is a huge leap.
Is that part of the year 3 of the 3-year strategy?
It is year 3 or year 3 plus 1 or 2. I wouldn't dare say that we are completely ready for this level of integration. There are so many parties involved.
What are the key takeaways for visitors and customers when they come to Nokia Oulu?
We do have our own share of visitors. We had somewhere around 200 visitors last year, so we have quite a lot of people coming to the factory. And usually they are amazed on the technological level that we have in the factory. We have the AIVs running around, we have robots doing parts of assembly that earlier on done completely by humans, and then of course we have the private wireless networking, meaning the LTE and 5G networking providing connectivity to our devices. On top of everything, we have the digital twin and its use cases that are already used in full production all the time. So I can say that some of our customers have asked, can we buy this somehow as a part of Nokia solution? But well, I can tell that at least not yet.
So if there was one takeaway for the listener to this conversation about the next generation of digital twins, what should it be?
I'm very keen on seeing what the industrial metaverse is going to bring in here. I cannot say that I have really captured what it really means for us, but when it happens, I want to be there.
Building a future that's productive, sustainable, and inclusive in a world that acts together. Discover how by visiting nokia.com/thought-leadership.